Recall that we talked about average blood pressure. The average blood pressure has a specific name or a specific term that we use to refer to it, and that's what we call mean arterial pressure. In a nutshell, mean arterial pressure is essentially an average of the pressure measured in the brachial artery for the average individual. And again, sometimes it could be measured in the thigh, but generally speaking, it's the brachial artery. And what we use to calculate average mean arterial pressure is that we need from our blood pressure cuff, we need to measure our systolic and our diastolic pressures in the brachial artery. From that, we can calculate our pulse pressure. Now, you remember if I were to diagram, say, a blood vessel here, and if this is the side that's closest to the heart, my pulse pressure at first, I'd have a high pressure here, but then you would see that pressure essentially moving along in a wave, and so we would have that high pressure system, etc., until finally we get to wherever we're going to go. And so that's essentially a pulse pressure. It's this wave of pressure that moves through the circulatory system, and that pulse pressure in the brachial arteries is calculated by the systolic pressure in the brachial arteries minus the diastolic pressure in the brachial arteries. And essentially pulse pressure represents the driving force. That's essentially that delta P, or that driving force that exists. Then we have mean arterial pressure itself, and the equation for mean arterial pressure is 1/3 pulse pressure divided by diastolic. Now you're going to see different presentations of the same mathematical equation. They're all mathematically identical. So I could write mean arterial pressure is equal to systolic minus diastolic. Of course, I didn't leave myself enough room. Systolic minus diastolic, and I'm going to divide that by 3, and then I'll add to it my diastolic. That's a lousy way to write it, but you get the basic idea. Or if I wanted to, because what we end up really doing, it's systolic, if I'm doing an average, systolic plus diastolic plus diastolic, and take all of that and divide it by 3. It's an average. Now why are we counting diastolic pressure twice? The answer to that is simply to do with the cardiac cycle. If you were to go back to your Wigger's diagram and look at that diagram in terms of just the timeline, we spend more time in the diastolic, in the ventricle filling phase, a lot more time in ventricle filling phase than we do in any of the other phases. And so that is actually quite relevant because the ratio is approximately 2:1. So we spend more time in diastolic than we do in systolic, twice as much really. And so that mean arterial pressure, that's where the 1/3 comes from. We're basically doing an average. So, you know, what's my average value? We have to count diastolic twice and then divide it by 3 instead of dividing it by 2. Now, mean arterial pressure, normal mean arterial pressure ranges, just to give you an idea, 70 to 100, give or take. Everybody has a little bit of variation there, but if we really get below 60, this value here, at that point we don't really have adequate perfusion of the tissues and organs. Now, as a reminder as to what perfusion is essentially the ability to provide a given area of tissue with blood. The more precise definition here is the passage of blood through the circulatory system to an organ or tissue involving that delivery of blood to the capillary bed, and we measure it by measuring the volume of blood per unit of time per tissue mass. And so you'll recall me talking about that. And if I don't get adequate perfusion, that can cause some significant problems. For example, lack of perfusion in the brain can cause things like memory loss, disorientation, dizziness, feeling of faintness, etc. And so it's important to remember how important this perfusion is. If we don't get adequate perfusion to the kidneys, we're not going to get adequate filtration, we're not going to get adequate regulation of blood volume or of blood osmolarity, and so on. If perfusion is especially low, we get what we call ischemia. and that tends to cause damage to tissues due to lack of blood flow. So that's kind of bad news. So a lack of perfusion could potentially result to damage to the brain, or damage to the kidneys, or damage to your left pinky, or what have you.